Okay, good morning, everybody. I'm starting my class. Today we will be talking about uh, using Clustal. It's not Clustral, it's Clustal W, and how to make multiple alignment. And then after making multiple alignment, you have to construct a phylogenetic tree on the basis of DNA or protein sequences. So you can have a DNA sequence or a protein sequence that you can treat as a character. Each nucleotide is a character in a sequence. Each nucleotide is a character in a sequence. So if you have 10 nucleotides or 10 DNA bases one after the other, uh, it is a sequence actually. So uh, in different organisms there may be nearly related organisms. Today we will be talking about bacteria. So in nearly related organisms, you will find that there are one or two nucleotide differences. So this particular phylogenetic tree construction using cluster, it can be done online on a particular platform where you can calculate on the internet the particular sequences. So I have already compiled the sequences, but we will go through the steps one by one. I will share my screen now. তোমরা কি এই পেজটা দেখতে পাচ্ছ? Are you able to see the screen?
Yes, sir.
Okay, okay. You are able to see the screen. একটু বড় করে দিচ্ছি, না বেশি বড় হয়ে গেছে। So the first step is the sequences. You have to retrieve the sequences, and the site is https. This is the site from which you retrieve the sequences. I will show you. For example, I have taken the sequence of E. coli 5S ribosomal RNA sequence. So ribosomal RNA, it's important in ribosome. It is important in ribosome. Ribosomal RNA, it is important in ribosome. আচ্ছা, শেয়ারিং এ আছে কি? দেখতে পাচ্ছ?
Yes, sir.
It's still there, na? Just hold on. I will. It's there. Okay, fine, fine, fine. So this ribosomal RNA, basically, this RNA is required in ribosomes. That is when proteins are made in translation. So this 5S ribosomal RNA sequence in all organisms, they are normally used for they are ideal target for use in phylogenetic tree construction, because all different, they are supposed to be very conserved, but there are little differences, and depending upon how many differences are among the between the sequences, ribosomal RNA of S. aureus or E. coli or Klebsiella pneumoniae or Microbacterium bovis. So these are all bacteria. We are using bacterial 5S RNA sequences. So based on this this the DNA of this RNA sequence. So this RNA is transcribed from DNA. So based on the sequences and the differences in the sequences, we can say which is close together. Organism A, B, C, D. Which of this organism is close with each other, which is far away from each other. You can construct a phylogenetic tree online. So the first thing is you go to this site, and for example, I want to first find the 5S ribosomal sequence of ribosomal RNA sequence of E. coli. So I go to this particular site. I First thing is I go to this. This is the particular website link address. So in nucleotide, under nucleotide, not there are lots of things, but under nucleotide, you want E. coli 5S R RNA. You want this, and you search it. So you already get the sequence over here. You can get different sequences. So I have taken this particular sequences, 5S RNA sequence. I've taken this particular sequence. You open this sequence, there is a number. This is known as the gene bank accession number X0. So if you say this is this number, you have to, whenever you are publishing or writing something, this number is the number which you always need to give. So this is the 5S ribosomal RNA of E. coli. It is 120 base pairs long. So, and all the details are there. And this is the particular sequence. TGCC, TGG, CGG. This is the particular sequence. Are you able to see the sequence? Yes, no, please tell me.
Yes, sir.
So if you are able to see, this is the sequence. So you cannot paste, use the sequence in this manner. You need to take it in a particular format known as FASTA format. So on the top left, you have this FASTA format. You go to FASTA format, you click. This is FASTA format. What is important in FASTA format? Let me increase the size of the screen. You will see that there is a greater than sign here. Are you able to see this greater than sign? Yes, no? দেখতে পাচ্ছ গ্রেটার দেন সাইনটা? এই যে এটা এখানে ব্লু কালার করেছি। হ্যালো? এটা দেখতে
Yes,
পাচ্ছ?
sir.
আচ্ছা। তোমরা রেসপন্ড করবে? So, and then you write E. coli or whatever you want to write after that to identify later. After that, you have something written. The E. coli 5S RNA ribosomal sequence. I normally write E. coli. I've written. So, this is the particular sequence. You copy this sequence and I have pasted it over here. The sequence has been pasted over here. In the similar manner, what I did was I got the sequence of S. aureus, 5S ribosomal, Staphylococcus aureus. This is another bacteria. Then Klebsiella pneumoniae. I've taken that 5S RNA sequence. Then I've taken the 5S RNA sequence of Mycobacterium bovis. This is the sequence I've taken again. And Salmonella. So I've taken 5 organisms, 5 strains: Salmonella, Mycobacterium, Klebsiella, Staphylococcus, and E. coli, Escherichia coli. Clear? I have pasted all of them in FASTA format. ঠিক আছে? বুঝতে পেরেছো? Is it clear? Yes, no? বলো একটু।
Yes, sir.
ওকে। যদি বুঝতে না পারো তাহলে বলবে। Please stop me. So I have taken the sequence from this particular NCBI site. Now, the next step is, of course, the second step. First step was sequences are retrieved. Then the sequences are to be pasted in FASTA format. So I go to this particular FASTA format. I have seen how you have taken it from the FASTA format and you have pasted it over here. Next is you go to this particular site. I've given this genome.jp.tools Clustal W online. Multiple sequence alignment by Clustal W. You go to this. Output format, you put as Clustal. You can put it in FASTA also, whatever you want. You need the output in Clustal. Fast, approximate is better. Slow, accurate also you can do, but it will take a lot of time. Let's do fast. Uh, let's do the fast one. কে ঢুকলো চলে গেল? ওকে, anyway, let's do the Rohit Kumar admit. So after admitting Rohit Kumar, so the here you are going to now paste this particular all the sequence. See how I have pasted it. I'm trying to increase the size. ওটা নিলাম, সোজা পেস্ট করলাম, আর ওপরে জাস্ট এই গ্রেটার দেন সাইনটা দিয়ে I have put equal after putting this greater than sign equali, and I have pasted the sequence. The next I have I did not write all these details. Otherwise, later there is problem. So you have this ANR, accession number, all these details are there. I have deleted all those things, and instead of that, I have simply put S aureus, K pneumonia, Klebsiella pneumoniae. I put the sequence. M bovis, Mycobacterium bovis, Salmonella enterica. So I put all these. So I want to make a phylogenetic tree and say which is closer, which organism is close to each other and how far is which organism. So you are trying to make a cladogram or a phylogenetic tree. So I have pasted it one after the other here. Clear so far? Yes, no, একটু বলো। এটা বুঝতে পেরেছো? হ্যালো, দেখতে পাচ্ছ কি?
হ্যাঁ স্যার।
হ্যাঁ, তো এটা বুঝতে পেরেছো সোফার আমি কি করলাম? সিকোয়েন্সটা
হ্যাঁ
পেস্ট
স্যার।
করলাম। আচ্ছা, ঠিক আছে। So next step is you have to execute multiple alignment. এদেরকে you want to align them one after the other to see where are the differences. অ্যালাইন মানে পরপর দাঁড় করালে সিকোয়েন্স গুলোকে, এখানে তুমি পেস্ট, ইউ হ্যাভ জাস্ট সিম্পলি পেস্টেড অ্যান্ড you are taking it one after the other. So you have to execute multiple alignment. So this is the Clustal W result which you get. So all these datas are there. এটা দেখলে E. coli আছে, so many these things are not important. What you need actually is this alignment. S aureus, S enterica, K pneumoniae, E. coli, M bovis. এবারে দেখলে এস অরিয়াস এন্ড এস এন্টারিকা দ্য ফার্স্ট টু নিউক্লিওটাইডস দেখো এদের এখানে নেই। এখানে দেখো 100% এই যে ইউ আর সিইং দিস স্টার সাইন ওভার হিয়ার, দিস স্টার সাইন মিনস দ্যাট দিস ইজ 100% ম্যাচ। আদারওয়াইজ এই দেখো যেখানে স্টার নেই, দেখো এখানে all of them have got a, where the star sign is not there, all of them have got a, this is T T T T, but here instead in this position you have got a C over here. So this is there is a difference. Already in M bovis you can see there is no nothing over there. It is different. So this is how an alignment is done. And these star ones, this G G G G G G G star ache, if you see this whole line, this is all aligned. এখানে দেখো these are 100% matches, যেখানে the star sign আছে তার all this whole line is 100% match. The other is not 100%, either one or two or three in one organism or the other organism একটা দুটো ডিফারেন্স আছে। এটা ক্লিয়ার কি? বুঝতে পেরেছো? ইয়েস নো বলো।
Yes, sir.
So this is the first line, this is the second line, this is the third line, all cannot be put in one line. So this is how you make a multiple sequence alignment. After this multiple sequence alignment, the next step is construction of a phylogenetic tree. So you have to select a tree menu, which type of tree you want. Any of this tree you can use. I personally prefer phi ml. This is phylogenetic ml, but you can use even fast tree full. This is, let us see all of them one by one. Let's see fast tree full, and then you execute it. Now this is being processed, your tree is being made. See, the result has come. দেখতে পেয়েছো? These are the organisms: M. bovis, S. aureus, E. coli, K. pneumoniae, S. enterica. From the sequence, you see that K. pneumonia and S. enterica are very close to each other on the basis of nucleotide DNA of different nucleotide sequences. This data is the distance which is given. This is not important. So you can, without branch label, you can remove this. So this over here, this point is the MC, the most common recent ancestor of K. pneumonia and S. enterica. And then this is from E. coli, and this is the most recent common ancestor of E. coli, K. pneumonia, and enterica. This may be extinct; it's not found. Then this is the most common recent ancestor of S. aureus, E. coli, K. pneumonia, and S. enterica. And here, this root is the common ancestor of all. So you can see that M. bovis is most far away. Mycobacterium bovis is more far away from one another, depending on the differences in the sequence and on the similarities of sequence. Similarities and differences. You are taking both of them together, and on the basis of that, you have created a particular tree. Source দরকার নেই, এটাকে বন্ধ করে দিই. So you can download this image in PNG format or whatever. PNG তেই আমি নিই. So this is something you can download and you can paste in your notebook. You get the phylogenetic tree construction by Clustal. And let us see. You can do it also without ticks. Nothing is there. So this is something also you can paste. So you can do it without leaf labels, no labels, but this is, you need the names. Without branch length, the branch length is not given. The number is not given. So you have I think this is the best way. You don't give the branch length, because examiners can ask the question. You can ask what is branch length. So the branch length is will be given. So read about what branch length is. এই যে এটা লেন্থটা কত সেটা এই ডিসটেন্সটা দিয়েছে, কতটা দূর, how far it is from one another. That is the branch length. Now you can even, let's close this, go to this result. This is the fast tree format. Let us do it in 5 ml format. Let's execute it. These are all phylogenetic tree construction. They are using a different protocol, but the principle is the same. The job is still running. And here is the result. You get the result. See, same thing. Enterica and pneumonia. They are close with each other. I think branch level এটাকে বাদ দিয়ে দেখো, এটাকে বাদ দিয়ে দাও. S enterica and K pneumonia, they are close with each other. This point is the most common recent ancestor of them. And of all these three, E. coli, S enterica, and K pneumonia, this point, this here, the extinct most common recent ancestor is present here. And among all of them, this is the most common recent ancestor of all. So this, you can download this image and you can paste in your lab notebook. I will give you what you need to write in your lab notebook. I will give you all the details. You have to take a printout and you have to attach it, put it in your lab notebook. আমি তোমাদের সব ফিউচার নেক্সট উইকের মধ্যে সবকিছু দিয়ে দেবো কিভাবে তোমরা করবে. So this is how you need to do it. এটা তোমরা কি দেখতে পেয়েছো? তোমরা উত্তর দিচ্ছ না কেন আমাকে?
Sir.
Is it clear?
Yes, sir.
Okay, it is clear. Fine, great. বুঝতে পেরেছো? পারবে করতে তোমরা নিজেরা এই জিনিসটা? কম্পিউটার লাগবে। হ্যাঁ না বলো, পারবে করতে? তোমাদের আছে কিন্তু ক্লাস্টাল ডাব্লু সিলেবাসের মধ্যে। Phylogenetic tree construction. This is how you construct a phylogenetic tree. So do you people have got any questions? একটু জিজ্ঞেস করো আমাকে যদি থাকে। হ্যাঁ কি না প্রশ্ন আছে? এখানে কে লিখেছে, এখানে কি লিখেছে দেখি। সোমেন ঘাটি লিখেছে ইয়েস স্যার। কোয়েশ্চেন কি আছে গো সোমেন? আছে কিছু কোয়েশ্চেন? এনি কোয়েশ্চেন্স? ওকে, নো কোয়েশ্চেন্স, নোবডি ইজ আনসারিং। ঠিক আছে, I will end my class over here. I will give it for your practical copy and you write it down. Okay.